Hello. Now that we've learned all of the rules of derivatives, I'm just going to take a moment here to talk about how one breaks down the process of evaluating derivative where you have multiple pieces going on. So let's take it as an example. Let's suppose that f of x is e to the x squared times x cubed. And so here we have a lot of pieces going on. We have a product of two functions here, and this left-hand function is itself a composition of the exponential function and e to the x squared. And so we look at all of this and we ask, all right, how do we go ahead breaking that down? So first of all, I look at this thing and ask myself, do I know how to differentiate a thing that looks like that? And the answer is no. We only have a short list of functions. We actually know how to directly differentiate some power exponentials, logs, and this isn't any of those. This is some weird combination of them. So I say, okay, can I express this as a product, quotient, or composition of functions? And it is technically possible to express this thing as a composition or a quotient, but it's not really very natural. The most natural structure seems to be that this function is a product of these two functions. So we'll go ahead and say, well, by the product rule, I can rewrite this as the derivative of the first function times the second function plus the first function times the derivative of the second function. All right, that's what the product rule states. And then we can ask very briefly, well, do I know how to differentiate this or that? And for that, I say, yes, I know how to differentiate x cubed. That, by the power rule, is 3x squared. And then I look at this and say, okay, do I know how to differentiate that? And again, no, this is not any of the things that we directly know how to differentiate. It's not exponential, it's not a power, it's not a log. All right, can I write that in a meaningful way as a composition or quotient or product? And well, it looks very naturally to be a composition, that the x squared is sitting in the argument of e to the x. So I'd say, okay, then since it's a composition, by the chain rule, I can express that as e to the x squared times the derivative of x squared. And then finally, I can ask myself, do I know how to differentiate x squared? And the answer to that is yes, again, by the power rule, that's going to be 2x. Right? And then finally, if I really felt like it, and this is not super necessary in my eyes, but to a lot of people this is somehow important, I can simplify these expressions, and it is a little nicer to look at. And if I want to factor out e to the x squareds or the x squareds themselves or some other thing, you can do that too. But we're basically done at this point. All right. Let's perhaps do one more example. Do you have space here? Yes. Let's consider the derivative of g of x equal to, let's say, x plus 1 over x times the natural log of x. And I ask myself, all right, what is the most natural way to write this thing? It's also clearly not any of the nice functions that we know how to differentiate, right? So it seems to me that this is most like a quotient of functions. So if I apply the quotient rule, I get the lower function times the derivative of the upper function minus the upper function times the derivative of the lower function, all over the lower function squared. Then I look at that and I say, all right, well, the derivative of x plus 1, do I know what that is? Yes, it's 1, right? So I just times 1, and I'll leave that alone. Minus x plus 1. Do I know what the derivative of x times natural log of x is? Well, it's not one of my standard functions, so I don't know how to differentiate directly, but it is the product of two functions. It is the product of x and natural log of x. So derivative first, second, plus first derivative, second. And this is all over x natural log of x squared, right? So once something's differentiated, I leave it alone, right? I'm not doing anything to it. Oh, that ran off the board a little bit. Let me adjust. And so in this next step, I can keep everything the same, and it's just a matter of resolving these two derivatives, not x and natural log of x. I'm not even going to write a whole new line. We both know how to differentiate these things, right? The derivative of x is 1. The derivative of natural log of x is 1 over x. And then 1 over x times x, that's just 1, right? And so this whole thing simplifies to x natural log of x minus x plus 1 times natural log of x plus 1. And this is all over x natural log of x squared. And as far as I'm concerned, that's good, and that's done. It's certainly true that if I were to expand this out, that probably more terms could cancel, and that this thing could be simplified, but that is no longer calculus. That's just algebra or arithmetic or whatever you want to call that. And so from now on, it's just symbol manipulation. No more thinking is to be done. And so as far as I'm concerned, we're done.